Okay, so this is the cover from Earth's Future, and it has a variety of pictures. The hot colors are more methane concentration change, and I'm not going to read off all of my co-authors. There are lots of them. So here's a close-up of the image. Turns out that the satellite Skiamaki has a nice spectrometer on it, and it has some sensitivity around 1.66 microns, so we can look at the reflected infrared radiation. So solar radiation reaching the Earth's surface and bouncing back into space. We'll capture the entire column content of methane. Now, the signal-noise ratio is not brilliant, so we had to average a 3-year time period here before oil and gas operations got really cooking, and then this 3-year period more recently. So doing a little bit of computation on the change in the concentration and the local winds, we managed to conclude that the leak rates for the Bakken were 990 kilotons per year from the Eagle Ford, a little bit less. This is a total of about 10% in total energy content. So this is in agreement with the high end. And I guess I should point out, there's a question I was going to ask the previous talk. I think that was production. And there's a lot of apparent disagreement between 0.44, 10% leak rates. And you have to be careful to be comparing apples to apples, not apples to pomegranates and kiwis, because this top-down technique measures total, drilling, production, shipping. There's a lot of flaring goes on in the Bakken. And just production can be a completely different number. Okay, so these, I should point out at this point that, that one of my co-authors, Paul Shepson, said that more recent work in the Bakken indicates lower leakage rates, primarily because a lot of the active drilling has slowed down. But notice the time period we're looking at here, centered around 2010. That was an active period. The gas prices, oil prices were a little bit higher then than they are today. Today they're probably about 50 cents a barrel or something. I lost track. All right, now what we couldn't do, we couldn't come up with a good, I blame this on the Genauigkeit that my German colleagues exaggerate a little bit, but we had good numbers for concentrations of methane over the Marcellus, but it's difficult to quantify there because, especially the winds, because we have mountains, there are some big lakes there, water doesn't have a very good reflectivity in the IR. So we see lots of leakage, but didn't want to put a number on it. So I'm going to talk a little bit now about some flights. That's in Indianapolis, for those of you who don't know Great Plains, Middle America geography, and this is where I come from. So one of the first things we did, there's been a project called Influx going on for a while, headed by Shepson, supported by NIST, in which they look at Indianapolis, and if you're from the Midwest the way I am, you like your cities simple and flat, unencumbered by large bodies of water nearby or by mountains or other cities nearby. So we flew both of these aircraft. They were both equipped with Picaros and a variety of other trace gas and aerosol instruments to take a look. And just a very brief, just a snippet of data from some flights we did this October. There was excellent agreement between the two airplanes, and we're trying to do a mass balance sort of calculation. That's Indianapolis. This is the general wind direction. So these for flights in the boundary layer, upwind, downwind flights. You can see increases in concentration of methane, both from general leakage from the city itself. There doesn't appear to be a tremendous amount of leakage in Indianapolis. It's not as old a city as Washington or Boston, some of the other cities that have been investigated. And there is a landfill in there that's doing some leaking. So we found those. You can see a pretty good increase in the methane on the downwind side. And this is the carbon dioxide on the downwind side, and likewise, we get a good signal there. And a quick estimate that we did from this one particular flight is at least in the same range as what's been observed previously. So the method appears to be working for capturing total greenhouse gas emissions from an isolated urban area. Well, if your objective is to understand total emissions, Indianapolis by itself won't work. So we also took a look at this is the Marcellus. It should be sort of vaguely green on there where the shale formation is, and these dots are showing the increase in the number of wells between 2004 and 2013. There'll be a quick quiz afterward. Which two states on here have called a moratorium against fracking operations? This is my home state, Maryland, and you can see that the bit of Marcellus that we have is pretty tiny out there. Maryland's not very big in that panhandle region. And New York, likewise, has a ban on new wells. But Maryland just lifted theirs. So there's lots of action going on there, especially most recently in Ohio. And we're going to take a look at this region. I just want to show some very recent flights we did right out there with a single instrumented aircraft. So this is the flight track leaving from Tipton Air Base between Washington and Baltimore, flying out here, and then doing as kind of a crazy pattern, and in this area south of Pittsburgh. So this is an interesting part of the world in that there are some mountains there. There's a lot of fracking going on in that part of the world. And there also is a lot of coal combustion. A lot of electricity is generated out here because that's where the coal is, and there's ample water to do that as well. So to orient you, for those of you who are not familiar with East Coast geography, so this is Washington and Baltimore, and we're going to look in that box out there, which is out where West Virginia, Pennsylvania, Maryland, and Virginia all kind of intersect. So this is the flight track, and superimposed on the flight track, color-coded is the concentration of methane. It doesn't go to zero, but the dark blue on there is sort of the background concentration. And the circles are sort of vaguely indicative of the concentration as well. But the hotter colors are more methane. So you can see three distinct areas where we saw substantial amounts of methane relative to the background, going up to almost 2.5 parts per million by volume. So even though this was winter and it's a very hilly area, we could still pick up a good signal there. It's not an unpopulated region, though. And you worry about other sources. So, I'm not going to show you a quantified value for this. These flights were made a week ago. But the technique that we're developing for understanding the total emissions for a given area, Indianapolis or the Marcellus or the Baltimore-Washington metropolitan area, will be to do a high-resolution WRF model done by some of my colleagues, and then instead of a model inversion, do an ensemble-Kalman filter for data assimilation and try to backtrack out what the emissions actually were. This is carbon dioxide along the track. We're in winter here, so the biosphere is not actively sequestering CO2, but you can see some increases. There's Morgantown, West Virginia, a small city. Pittsburgh is up here. We're not really close to Pittsburgh. So you can see some background down there and concentrations up over 420. This is the sulfur dioxide along the same track. We have other trace gases as well, but don't have time to show everything. And so it's a relatively simple SO2 monitor that's just a pulse fluorescence, but it works well enough to identify plumes. The background here is below a part per billion, but there are power plants all throughout this region, and we managed to fly through some of those plumes. So this is a nice diagram that is a scatter plot of the methane concentration basically above background, the CO2 concentration above background, and it's color-coded according to the SO2 concentration. So you can see with high confidence that we can identify the free troposphere where all the concentrations are relatively low. Urban areas that have high concentrations of carbon dioxide but don't have very high, a little bit of increase in the methane. Specifically power plant operations here, where you have some increase in CO2 and a substantial increase in SO2. We hope to take a look at those specifically and look at the relative increase in SO2 over CO2 to evaluate the CEM systems, continuous emissions monitoring systems that EPA requires power plants to operate. Some of these plumes are not entirely clear what they are, some mixed urban possibly fracking, possibly some coal combustion there. But clearly there are some very distinct plumes that we picked up from methane from the mines, drilling operations, production, shipping out there, where concentrations went up pretty high. One of the reasons I ask about the CO2 methane ratio that the cattle were producing is you would be able to see on here if there was a big dairy operation that the CO2 would be positively correlated with methane, and that's not happening, at least for this particular day. All right. What's next? There's a new project, sort of an expansion of influx. We call it FLAG Maryland, for flux of atmospheric greenhouse gases in Maryland. And it's going to be a little more difficult to fly the airplane around there because the FAA gets a little fussy about this air traffic in this particular region. But it is possible to do some upwind and downwind flights. And the concept is we'll bring the Purdue Duchess and fly the University of Maryland Cessna at the same time and attempt to do this kind of a mass balance closure technique to get a handle on the total greenhouse gas emissions and other trace gases as well. But it's going to be quite a bit more difficult because we have mountains here and a large body of water that can generate bay breezes and so on. So the first big flights we have planned, actually, there's a little advertisement for our colleagues from NCAR and Washington and NOAA. There'll be a winter project. Winter is the name of the project, and it'll start February 1st, go into March 15th. Their objective, Steve Brown and Joel Thornton, are really interested in aerosol chemistry in the winter and some of the interesting nitro chloride and so on reactions that can happen. But they'll also have a Picaro. So 3 airplanes at once, we should be able to get a pretty good handle, even do some Lagrangian experiments, is what we're hoping for. All right, so in conclusion, let me just say that SKIA was a wonderful tool. Alas, NVSAT has fallen asleep. John Burrows likes to say that she's just sleeping beauty, and with the right kiss, we'll bring her back to life. So maybe it'll come back to life at some point, but currently it's dead. But that instrument did indicate agreement with a high end of total fugitive emissions for methane. We have had some success with a 2-airplane campaign. We're looking forward to the 3-airplane campaign this winter. And finally, the technique that we're developing for a complicated meteorological situation will involve high-resolution WRF modeling coupled with some clever data assimilation techniques, which we hope will then backtrack out the total emissions of different trace gases. So, thank you.
Thank you. Do we have any questions?
Hi, thanks for the talk. Really interesting. I want to know how you get your source attribution to fracking as opposed to other fossil sources of methane.
You mean from the satellite work?
No, from the Marcellus flights.
Oh, the aircraft flights we did last week. Well, what would be the other possible source? There is a great deal of natural gas operations going on out there. If there were other sources like dairy cattle, then you would have seen a positive correlation with carbon dioxide from the dairy cattle. It could be leakage. I mean, I suppose Morgantown, West Virginia could have a leak that is 100 times higher than any other city. That seems unlikely. Well, the other method is, I'm sorry, absolutely, there is coal mining going on out there at the time. Yeah, and coal mines have been observed to generate some methane. The particular location where we were flying was near gas operations. You could see it out the window of the airplane. And we did fly by some coal mines, and when we went by there, Shepson saw a lot of emissions from a particular coal mine in that part of the world. We did not. So on the day that we were there didn't appear to be a lot of methane coming out of that coal mine.
Thank you.
What's the turtle? We fear the turtle. We have the fighting terrapins is what we are. So I've got 10 seconds. There was one more question.
I was just wondering, you didn't give numbers for the leakage rates of Marcellus, I don't think, and yet here at the very end it says high end of the emission.
Yeah, well, as I was alluding to, my German colleagues were reluctant to come up with, the error bars on the Eagle Ford and the Bakken are pretty good. They would have been even better on the Marcellus. There was a substantial increase if you averaged over those years, but you can't get a flux unless you can get something from the winds. And the winds in the mountains were highly variable. So if you look very carefully at dig into that publication, you'll see there's an estimate that it's at the high end, but it's not quantified. So, thank you.